is actually changing. You're not just continuing along that slope. And then that's your current weight update, and then you update these values. You update your current weights in accordance with the traditional weight rule. Does anybody have any questions on that? All right, and then training with it is basically pretty much the same process that we've been talking about for this whole time. So you're not doing anything different in terms of, and then for every layer, you're going to compute those gradients and then update the layers. Do this until the errors converge. If you're doing it with momentum, on the other hand, then you're going to actually do pretty much the same thing. You're just going to be keeping track of your gradients, and then you're going to be updating them according to this rule, so that you're keeping track of your previous weights, or your previous updates, and changing them as time goes on. Yeah, so this is the same approach, but this is kind of just a visualization. So the first thing you're going to do is you're going to compute the gradient at the current location. So if you were just doing typical gradient descent, you would just take the blue step. But because we have that carryover from the previous step, you're now going to be including that red update as well, which is just the gradient from the previous step. And then it's going to add it into the previous one, or add it into your current gradient, and then make an update according to that. So obviously it's not necessarily an optimal step, but the way that the reason why this is super helpful is because it helps very well with saddle points or with potential smooth points in your error surface. So that if you were in gradient descent and you were traditionally going to get stuck in a saddle point or in a position with a gradient of 0, then you could actually sort of roll through that point without adding any error to without adding any value to your gradient, and then you just keep rolling until the gradient actually ends up changing. Yeah, so you can change the order of the operations and make things a little bit easier. So you can extend the first step, and then once you're at that extension, you can then proceed in that direction. So you're getting a slightly more optimal step. So if you were to have just calculated the gradient from this position, you get a smaller update, or you get a smaller component there. But if you're proceeding in this direction and it's potentially a non-optimal step, you're actually, because here we're actually, if we were to just take that red step, we'd be increasing the gradient a lot more. So we get a little bit more of a push in the optimal direction. So yeah, it's just the order in which you calculate, as opposed to calculating the gradient from the starting point. You calculate it from the momentum point. There's another approach called accelerated gradient from Nesterov, but the idea is basically that you're calculating the error. I'm sorry. So this is just the mathematics of this approach. So you flip the order of operations here. So you've got your beta value here, which is the back off from your weights at your previous step, k-1, added to the weights, calculate the error, and then you update the weights according to that. So this is just the mathematics of that change in the order of operations. Comparison with momentum. I believe this is from Hinton paper. It tends to converge a little bit faster, but it changes. So this is now training with momentum, and then just revisiting the original thing. So this is not, I don't believe this is Nesterov's method. This is just the original momentum thing to recap. So we're going to talk about this a little bit more on Monday. And that's about it. So the professor is going to be back on Monday. He's going to be giving the lectures from now on, I believe. Thank you guys for putting up with me. I appreciate it. One quick note, I'm sure you guys have been seeing the homeworks, been getting updated a little bit. Make sure to re-download everything. There haven't been any changes or anything like that, but make sure you keep an eye on it.
Only if you haven't looked at it, like if you download it prior to I think to Monday.
Yeah, if you download it on Monday, then you're all good. But just make sure that you download it. You look on Piazza and make sure you got the most current version. There haven't really been any changes since Monday, but keep an eye out. Thanks, guys.